Hello, calculus. Let's look at problems 3 through 5. For number 3, we are in quadrant 1, and we're between the square root of x, which is this curve right here, and we have the linear function y is equal to 1/3 x, which is right here. So if we shade in that little tiny region, it's right there. Pretty easy to see. Okay, so now I like to reflect. So if I reflect the line across the axis of rotation, and then the curve comes around like this, again, that's very, very rough. Now for our rectangle, since we're rotating it along the x-axis, our rectangle has to be vertical. It has to be perpendicular to the axis of rotation. So there's our rectangle. As you can see, the top of the rectangle is on the curve, and the bottom of the rectangle is on the line. So our inner ring is the line. The line is closest to the axis of rotation, and our outer ring is the curve. So when we set up our integral, we will be doing the curve minus the line. All right, this is rotating it around the x-axis, so this needs to be a dx. Everything matches for volume. It matches the axis of rotation. All right, so we need a pi y squared minus pi y squared. All right, I like to factor out the pi. We need 3 sets of parentheses, so we need y squared minus y squared, and then our dx. So again, you need 3 sets of parentheses to make sure that this gets distributed. All right, let's put in our curve. Our curve is the square root of x, and our line is 1/3 x. All right, we are going to simplify that because we want something that's easy to punch into our calculator. When we square a square root, that drops out, so that simplifies nicely to x. And when we raise one power, when we have an exponent, outside a set of parentheses, everything in here has to get squared. So if we square 1/3, 1/3 times 1/3 is 1/9. And then when we square x to the first, when we raise one power to another, we multiply. So we have x squared, 1/9 x squared. There we go. The next thing we need, or the last thing we need for a definite integral, are my limits, my left and right endpoints. Everything matches the axis of rotation. So our limits are along the x-axis. So we need to find the points of intersection. This one right here on the left is definitely easy to tell. That is the point 0, 0. The point up here, the farthest point on the right, if you check your calculator, and you can also easily see with this graph, that point is over 9 and up 3. So again, we want the x values from left to right. So we want from 0 to 9. So we're going to put that in here, 0 to 9, and then we have a definite integral. Right now, for a washer problem, you may use Math 9. So go ahead and do that right now. Be sure to check your solutions. Okay, for number 4, we're going to take the exact same region, but now we are going to reflect it across the y-axis. So if we reflect that line like this, and we kind of reflect the curve, let's put in our rectangle. Now we need a horizontal rectangle. All right, so now the line right here is farthest away from the axis of rotation, the right of the rectangle, and the left of the rectangle is on the curve. That is closest to the axis of rotation. So now when we set up our definite integral, it's going to be, once again, different. It will be the line minus the curve. This is rotated around the y-axis, so we need a dy. All right, so we need a pi x squared minus a pi x squared. Remember, when you rotate across the y-axis, all of your equations have to be x is equal to. So let's take care of that algebra right now. We need to solve our equations for x. So if we go off to the side, if we take y is equal to the square root of x and we solve it for x, we just need to square both sides. So the square root of x squared is x, so x is equal to y squared. Alrighty, so that is our curve. Now if we take our line, y is equal to 1/3 x. If I want to solve that for x, the easiest thing I can do is multiply that by its reciprocal. Multiply this side by 3/1 and multiply this side by 3. Multiply both sides by 3. So then these cancel. X is equal to 3y, and that is our line. All right, so now let's go back over here and plug those in. All right, so we're going to factor out the pi. We need an x squared minus an x squared. All right, our line is 3y. And then just like we did over here, our curve is y squared. Okay, let's simplify that. All right, this one is pretty easy to simplify. Again, everything in this set of parentheses gets squared. So 3 squared becomes 9. Y to the first squared becomes y squared, so 9y squared. Over here, y squared squared is y to the fourth. Okay, the last thing we need are our limits. Remember, everything matches the axis of rotation, so we need the y values. All right, so the y value right here, of course, is 0. So that is our left endpoint, 0. And then over here, ooh, this point, that is not 0, 9. Excuse me. That point up here is, of course, over 9 up 3. We need the y value. So our 3 goes right up here. Alrighty, so there we have it. There is our definite integral. Go ahead and you may use Math 9 to solve that. Please check your solutions. Okay, lastly, number 5, we are again rotating this about the y-axis. We have the curve, the square root of 2x is right here, and then we have the vertical line x is equal to 2. So we go over to 2 and we put in a vertical line right here. That is the line x is equal to 2. So our region that we are rotating is this piece right here between the curve and the line. So if we shade that in, and then we put in our rectangle, remember this is a this is a horizontal rectangle. So the point on the line is farthest away from the axis of rotation, and the point on the curve is closest to the axis of rotation. If we reflect those, we can see our inner ring connects the curve, and the outer ring is the line. Okay, so let's set up our definite integral. Again, we are doing the line minus the curve. All right. Remember, when we rotate about the y-axis, we have to solve our equations for x. So let's take y is equal to the square root of 2x. In order to solve that thing for x, the first thing we have to do is get rid of that square root. So we are going to square both sides. So we have y squared is equal to 2x, and now we need to divide by 2. So I'm going to write that as 1/2 y squared is equal to x. That is our curve. Our line is already solved for x, so we don't need to worry about that. All right, so we need pi factored out. Then we need our two rings. We need an x squared minus an x squared. So if we do the line, we just plug in 2 squared, and if we do the curve, we plug in 1/2 y squared. So again, it's all y's and dy's here. All right, I'm going to simplify that. Right here, 2 squared, that easily becomes 4, much easier to plug into our calculator. Over here, everything in that parentheses gets squared. So 1/2 squared is 1/2 times 1/2. That gives us 1/4 y to the 4th. And then dy. Now the last thing we need for our definite integral are the limits. All right, this is obviously the farthest part of the region on the left, and that y value is 0. All right, this right here is the farthest part of the region on the right. That point of intersection up here is 2, 2. Again, we need the y value. So our upper limit is 2, from 0 to 2. All right, so there is our definite integral. Go ahead, you may use Math 9 for washer problems in calculus. All right, thanks, calculus.